Let's discuss the solutions to the midterm exam on Calculus T, which was taken in summer semester 2018. Exam contains 10 problems. We're going to go through all of the problems and try to explain the full solutions. So in the first problem, we're given a T vectors in a three-dimensional space with some parameter A here and here. So we need to find the proper values for the A so that these two vectors become parallel, and we need to find the values for this A, probably different values for the A, where the vectors are going to be perpendicular. So please note that the T vectors are parallel when we talk about the position vectors, of course, if one of the vectors can be obtained by scaling the another one, right? One of the vectors is obtained by multiplying the second one to some constant T, right? So let me write down the U as 1, A, and 2, and V is going to be A, 4, and 4, right? So from here, I can see that the scaling parameter is equal to the 2, right? Because if I multiply the T to the 2, this is going to be 4. From here, we can obtain that the multiplied to the 1 is equal to the A, or T multiplied to the A is equal to the 4. And the only condition for this, the only value for the A which is going to be satisfied, is equal to the 2. So when A is equal to the 2, these two vectors are parallel. So the vectors are perpendicular when their dot product is equal to the 0. So I need to just write down the vector U, which is going to be 1, A, and 2. And vector V has these three components again, A, 4, and 4. And its dot product should be equal to the 0. So let me write down the dot product. It's going to be A plus 4A plus 8 is equal to the 0. So from here I can find that the A, 5A is equal to the minus 8. So that is why the A is equal to the minus 8 over 5. For this value of the A, these two vectors becomes perpendicular. The second problem is on a series. We need to evaluate the sum of the series. So in order to do this, let us write down a couple of first terms. When n is equal to the 0, it's becoming simply 1, right? So when n is equal to the 1, it's because it becomes minus 1 over 2. When n is equal to the 2, it's going to be plus 1 over 4, then minus 1 over 8, plus 1 over 16, and so on. Right? So this is an example of the geometric series where the first term is going to be equal to the 1 and the common ratio is equal to the minus 1 over 2. So when we are dealing with the geometric series with the common ratio, which is between minus 1 and 1, we can use the formula in order to find the sum, right? So 1 minus 1 over 2 plus 1 over 4 minus 1 over 8 plus 1 over 16, and so on, until the infinity is going to be equal to the A1 divided to the 1 minus R. This is equal to the 1 divided to the 1 minus 1 over 2, right? This is going to be 3 over 2 on the denominator. If I take its reciprocal, it's going to be 2 over 3. So the sum of the series is equal to the 2 over 3. Problem number 3 is on the analytic geometry. We're given a T-planes, and we need to find another plane which is perpendicular to this T-planes and which passes through the point. So please note that if we're given a normal vector of a plane with the coordinates A, B, and C, and if we're given some point P0 on the plane, we can find the equation of the plane using the formula. It's going to be ax plus by plus cz is equal to the d, where the d is obtained by multiplying the a to the x0, b to the y0, c to the z0, and summing them. So we are given a point on the plane and we need to find a normal vector. So if the plane, our plane which we would like to construct, is perpendicular to these two planes, it means that its normal vector n is going to be perpendicular to the normal vector of these two planes, right? So the normal vector of the first plane has the coordinates 1, 1, minus 1, and the normal vector of the second plane has the following components: t minus 3 and 4, right? So when we copy the coefficients before x, y, and z, you can write down the normal vectors of the planes. So the n, which is the normal vector of our plane, should be perpendicular to both of these t normal vectors. And we can obtain this by multiplying these t vectors as a cross product. So basically I need to multiply 1, 1 minus 1 to the t minus 3 and 4. Okay, so we can multiply these t vectors as a cross product using the determinant of the matrices. I need to write down ijk on the first row of the matrix, then 1, 1 minus 1 on the second row, and t minus 3 and 4, which is the components of the third vector, the second vector, on the third row. So this determinant is equal, when we write down the I, multiplied to the determinant of the matrix, which is obtained by crossing out the row and the column where I is located. It's going to be 1 minus 3 and 4 minus j multiplied to the determinant of the matrix is obtained by crossing out the row and a column where j is located. It's going to be 1 minus 1 t and 4 plus the k multiplied to the determinant of the matrix, which is obtained by crossing out the row and the column where the k is located. It's going to be 1, 1, t minus 3. So now let's just find the determinants and write down the cross product. It's going to be I multiplied t 4 minus 3 minus j multiplied t 4 plus t plus k multiplied t minus 3 minus t. So this is going to be I minus 6j and minus 5k, or simply we can write this down as a 3-tuple is 1 minus 6 and minus 5. So the components of the normal vector to the plane has 1 minus 6 and 5, and the components of the point is 1, 0 and minus 2. So p0 is 1, 0 and minus 2. So the equation of the plane is going to be 1x, right? Because this is A, B, and C, minus 6y minus 5z is equal, when we multiply this vector to this vector as a dot product, it's going to be 1 plus 0 multiplied to the minus 6 minus t multiplied to the minus 5, right? So this is going to be x minus 6y minus 5z is equal to 11. This is the equation of the plane which we wanted to construct. Problem number 4 is we need to find the distance between the point and the plane. So in order to do this, let me draw them. So this is the plane, and we are given a point here. P0 was the coordinates 1, 0, and minus 2. So what I want is, I would like to find the distance between this t point, between this point, onto the plane, right? So please note that what I would like to do first of all is I would like to choose one point on this plane, and I would like to make a vector, right? And this vector is going to be p0 vector, p0 vector, and I know how to find this angle, right? So alpha. So this is going to be the same angle as between this vector, red vector, and the normal of this plane, right? So if you're given the vector u, and if you're given the vector normal vector n, we can find this angle. So you can ask me why we need this angle. This is because the length of this vector is actually equal to the distance between the point and the plane. And I can find the length of this vector using the cosine of the angle, right? So u norm multiplied to the cosine of the angle, cosine of the alpha, is going to be equal to the distance between the point and the plane. So I can write down this norm of the u. Cosine of the angle is between the u vector and the n vector can be found by multiplying u to the n and divide it to the u norm, multiply to the n norm, right? So I can cancel the u norm and u norm, and what is left is u dot n, the scalar product of the u to the n, divided to the norm of the n. Now obviously we need to take its absolute value. So let us the only thing which we need to construct is this vector u, because we are given the normal vector of the plane was the components t, minus 3 and 4, right? I need to copy the coefficient before x, y, and z, and this is going to be the normal vector. In order to construct this vector u, I need to choose one of the points on the plane. This can be any point, and if the equation of the plane is given in the form tx minus 3y plus 4z is equal to the 5, I can find one of the points on the plane by choosing any value for the x and y and choosing the value for the z here. So let's choose the x to be equal to the 0 and y is equal to the 0. If I substitute them to here, I can find that this is going to be 0 minus 3 multiplied to the 0 plus 4 multiplied to the z is equal to the 5. From here we can find that the z, which is going to satisfy this equation, is going to be equal to 5 over 4, right? Z is equal to the 5 over 4. So let's say this is going to be a point, right, because it satisfied the equation of the plane. So and this is going to be our point P. Was the coordinate 0, 0, and 5 over 4. And this vector u is obtained by subtracting this ending point of the vector with the components 1, 0, minus t, minus the starting point of the vector. It's going to be 0, 0, 5 over 4. So if I subtract this, it's going to be 0, 0, minus 2 minus 5 over 4. So you can write this as minus 13 over 4, right? It's going to be 1, 0, minus 13 over 4. So what we need to do is we need to multiply the u to the n and divide this to the norm of the n, and we need to take its absolute value. So the norm of the n can be found by taking the square root of the components, right? So please note that the n has these three components, t, minus 3, and 4. And the norm of this is going to be 4 plus 9 plus 16, right? And when you multiply the u to the n, it's going to be t minus 3 and 4 multiplied to the 1, 0, and minus 13 over 4. So this is going to be equal to, if I simplify this here, it's going to be square root of 29, right? If I multiply this vector to this one as a dot product, it's going to be t minus 13, right? And I need to take its absolute value, and this is going to be equal to 11 over square root of 29, because please note that the distance cannot be negative, so that is why we need to always take its absolute value. Problem number 5 is on the vector functions. So let's say we're given a vector function and we need to find its lengths, arc lengths, and where the t is going to change from 1 to the 3. So the arc lengths of the vector function is when we find the derivative of this function and we find a norm of the derivative of this function and integrate this from 1 to the 3 with respect to the t. So let us first of all find the derivative of this function. This is going to be the derivative of each of the components separately. So this is 1. So when we take the derivative here, it's going to be 4 over 3 multiplied to the 3 over t multiplied to the t in the power of 1 over t in tt. If we simplify this, it's going to be 1. We can cancel them out. It's going to be t in the power of 1 over t and tt. So when we find a norm of this vector, this is going to be the square root of 1 plus. So this thing in the square, it's going to be 4t plus 4t squared, right? And actually I can write this down as the square root of 1 plus t in the square, right? So now we need to just substitute this to this formula, and this is going to be equal to the integration from 1 to the 3 square root of 1 plus t in the square is going to be simply 1 plus t. The integration with respect to the t, right? If we integrate this, it's going to be t plus t squared. We need to evaluate this at the 3 and 1. If we substitute the 3, it's going to be 3 plus 9. If we substitute the 1, it's going to be minus 1 minus 1. So this is going to be equal to the 10. So the arc length of this vector function is going to be equal to the 10 when the t's change it from 1 to the 3. Problem number 6 is when we need to test the following series on a convergence, right? So the first thing which we need to do always when we test a series for the convergence is we need to take a sequence, find its limit, and this limit, when n goes to the infinity, should be equal to the 0. This is the necessary condition. If it is not fulfilled, then we stop the test immediately and we say that the series is divergent. So when we write down the series in this form, so 3 plus square root of 3 plus 3 square root of cubic root of the 3 and so on, the general term of the series can be written as the 3 in the power of 1 over n, right? So 3 in the power of 1 over n. Because please note that this is 3 in the power of 1, this is 3 in the power of 1 over t, this is 3 in the power of 1 over 3, and so on, right? When n goes from 1 to infinity. So our an is equal to the 3 in the power of 1 over n. And when we find the limit of an, when n goes to the infinity, this is going to be equal to the limit. So we can power out the limit. It is the same as finding the limit of here, 1 over n when n goes to the infinity. And this is actually equal to the 0, right? 1 over n goes to the 0 when n goes to the infinity. So that is why it's going to be 3 in the power of 0, which is 1, and which is not 0. So that is why the series is divergent. So the sum is going to be equal to the infinity, actually. Problem number 7 is we need to test the following series for the convergence using the integration test. So if you remember, we are going to write down the an as the f of n. It's going to be 1 over 3n. Then we're going to integrate this from 1 to the infinity, f of n dn. So this is the integration from 1 to the infinity of 1 over 3n dn. If you integrate this with respect to the n, it's going to be ln of 3n, right? Multiplied to the 1 over 3. And we need to put the 1 in infinity. If I put the infinity, it's going to be ln of infinity. Minus, if I put the 1, it's going to be 1 over 3, ln of 3. And actually, ln of infinity is going to infinity because ln is monotonic increasing function. So this is the infinity. It means that this integration is divergent, so that is why this series is also divergent. Problem number 8. We need to use a comparison test to determine whether this series is convergent or divergent. So, okay. So the series is n cubed 2n4 plus 1. So I think the series is very similar to the n cubed to the n4 series, which is very similar to the 1 over n series, right? So what I need to do is I just need to show that the series is okay. Actually, this series is smaller than this, right? Always. So since the denominator of the series is always bigger than the denominator of this one for all the values of the n starting t, then this series is going to be bigger, right? Because its denominator is smaller. So I know that this series is divergent. Okay. Or actually, let's use the limit comparison test here. So the limit comparison test here tells me, so if I I'm given a series with the general term n cubed divided to the t n4 plus 1, and I'm going to choose another one as the 1 over n. So when we find a limit of an divided to the bn, if this limit exists, then both of the series are convergent or divergent at the same time, right? So let's find this. Limit of n goes to infinity. It's going to be n cubed divided to the t and 4 plus 1 divided to the 1 over n, right? So 1 over n goes up, and I can multiply this to the n, right? So this is going to be the limit of n goes to the infinity, n in the power of 4 divided to the t, n in the power of 4 plus 1, right? So I can divide the both numerator and denominator to the n4, and this is going to be limit n goes to the infinity 1 divided to the t plus 1 divided to the n4. When n goes to the infinity, this term goes to the 0, and what is left is 1 over t. So if this limit is the constant, then the behavior of the an and bn are similar. It means that since bn is divergent, then an is divergent as well. Problem number 9 is if the limit of an goes to the 0, when n goes to the infinity, this means that the series is convergent always. No, of course, right? Because there is an example of divergent series. So counterexample. So if there exists at least one example where this doesn't work, it means that this doesn't work in general. So this is an example of the divergent series, right? This is called the harmonic series, where the an in the limit when n goes to infinity is equal to the limit of 1 over n when n goes to infinity is equal to the 0, but even though the series is divergent. So this doesn't work always, right? But you need to check this because this is necessary condition so that the series is convergent. So find the first 4 non-zero terms of the Taylor series for this function around the center a is equal to the minus 1. So please note that when we're given a function, and if we would like to write this in the Taylor series, we need to use the formula. So this is going to be f of a plus f prime of a multiplied as x minus a plus ft prime of a multiplied as x minus a and the square divided to the t, f3 prime of a multiplied as x minus a and the cube divided as a 6, and so on. So if f of x is equal to 1 over x, then f of a is equal to minus 1 over 1, actually, right? This is going to be minus 1. Since a is equal to the minus 1, I can just substitute the a to the x. So this is actually can be written as x in the power of minus 1, right? So when we take the first derivative of this function, this is going to be minus 1 multiplied as x in the power of minus t. And we need to evaluate this when x is equal to minus 1, right? This is going to be minus 1 over x squared. We need to evaluate this x is equal to the minus 1, and this is going to be simply minus 1. So now let's find the ft prime of x. Is going to be minus t plus t x in the power of minus 3. When we evaluate this, when x is equal to the minus 1, it's going to be minus t. So now let's find the third term. It's going to be derivative of this. It's going to be minus 6 in the power of x in the power of minus 4. When we evaluate this, when x is equal to the minus 1, it's going to be minus 6. Okay, so now we just need to substitute all of them to the series, right? So the first term is minus 1. So the second term is, again, minus 1 multiplied to the x plus 1, right? So this term here is equal to the minus t divided to the t. It's again going to be minus 1 multiplied t x plus 1 in the square, right? When we take the third derivative and evaluate this at the a, it's going to be minus 6. If I substitute the minus 6 here, it's going to be again minus 6 over 6, it's minus 1, right? multiplied as x plus 1 and the cube and so on. So you might guess that the next term is simply minus x plus 1 in the power of 4 and so on.